Good day everyone, welcome to our presentations video. I'm glad to be here with you guys today, but let me introduce myself. My name is Nur Fitri Zaini, and today I will tell about introduction and the objective. So our goals for today is to share and to explain about our mini project that we have done, which is Muruku Maker. So before we go too far, let's start our presentation and we're gonna start with introduction. For the introduction, torsional loading is a task that twists a material or test component to a specific degree with a specific force or until the material fails in torsion. The twisting force of a torsion test is applied. The rotating moment may also be applied to both ends of the sample, but the end must be rotated in opposite direction. Next, for the objective, for the first one is to draw details FVD from actual structure related problems. Second, to develop equilibrium equation for the FVD drawn. And the last one is to analyze force members from the structure.
Hi and Assalamualaikum. My name is Muhammad Haziq bin Suhaimi and I will explain to you guys about the dimension and the specification of our product. And let's go. So, our product is actually a Muruku maker, which is made of a stainless steel, and the weight itself is around 0.13 kg. There's a few parts in our product, which is the rod itself, the cylinder case, and the cylinder cover. But since we're in torsion loading topic, I will talk about the diameter of the rod itself. So the length of the rod itself is about 104 millimeters, and the height of the handle of the rod is around 95 millimeters. You can see in the picture. And don't forget about the diameter of the rod itself, because it gives value to our calculation, which is the diameter of the rod itself is 10 millimeters. And lastly, the shear modulus of this rod is 77.2 gigapascal. And now you know our specification and dimension of our product. Thank you.
Okay, this is the free body diagram for our tools, Muruku makers, and this is the length for LA. We assume that is 95 mm, and this is the forces that we need to find in our calculation, and this is the moment after we get the maximum shear stress. So next step we will explain in calculation.
Hello, my name is Muhammad Iqmal Hakim bin Roslin. Now I am going to show you on how we develop the equilibrium equation for FBD drawn. So the first formula that we use is formula for polar moment, which is J equal to pi r power of 4 divided by 2. And then we get the value for polar moment is 9.817 times 10 power of negative 10. Now for the second step, we need to find the maximum shear stress by using the formula of resultant internal torque multiplied by radius and then divided by polar moment. So after inserting the value into the equation, and then we get the answer for resultant internal torque is 15.157 kilonewton meter. So we assume that the shaft were broken at 15 kilonewton meter. The third step is to find the forces using equilibrium equation of moment. By assuming that summation of moment equal to 0, and then inserting all the value of forces involved in the system, now we get the value of F is 157.9 kilonewton meter. Now we are going to calculate the factor of safety. So the formula for factor of safety is maximum shear stress divided by actual shear stress. After inserting all the value into the calculation, and we get 389 for the factor of safety. As the value for calculated factor of safety is positive, so we assume that the shaft is safe in this working condition.
As a conclusion, based on the tool that our group already analyzed, we can conclude that the calculation and the approach of this mini project are based on the learning outcome of teaching, where we're able to apply in our method, and we can get the idea how to use the formula, such formula of torsion, torque, and the maximum yield stress. So that we can conclude from this mini project that the relationship between the angle of twist at any point along the road and the shear strain within the road. Next, we can conclude that our mini project is regarding to the Hooke's law principle. Besides that, the way of the working or being called body diagram, shows how the tool apply the moment and the forces toward the tool that are being examined. So that's all from our team. I hope you guys enjoy the video.